Have you ever read a research paper and wondered how the heck the authors came up with the methodology? In this short tutorial, I will show you 5 patterns in deep learning research that are common in method section. In every research project, there is always a bit of bias introduced by the others. Being aware of the thought pattern elevates your understanding of the result and their limitation. For those that are new to the channel, I'm Yassine, a published researcher and machine learning practitioner who loves to teach. Let's get into the patterns. One thing to keep in mind though is that all research is embedded in its own context and that it is usually incrementally adding a few new ideas to a pre-existing backbone. How these ideas are added or recombined is what makes the novelty. Be aware of this. Okay. The first pattern is the simplification. The simplification pattern usually comes around just after something groundbreaking was built out, but that has a lot of craft around it. Sometimes a lot of things that were built could just be reconfigured in a simpler way to get even better results. A very good example of the simplification pattern is ResNet. The authors used the simplification pattern in two specific ways. The first obvious simplification was on the type of function they were trying to approximate in the neural network. Instead of trying to approximate any function, they decided only to approximate residual functions. They forced this type of learning by simply having a bypassing connection from the input to the output of each blocks of layers. The second kind of simplification the author did isn't explicitly said, but it is quite apparent when you look at the timing of their paper and the highway network paper. A highway network is kind of like a residual network, but a bit more complex, a bit more LSTM-like. Residual neural network can be seen as being a subset of highway network in which only one of the connection is used. It's not exactly similar, but close enough. We'll get back at the timing bit of these two papers at the end of this video. The simplification pattern can also be seen in DenseNet, an improvement over ResNet introduced afterward, where the idea was that instead of forcing a dedicated residual connection, the network could just concatenate the input together and jam it forward, effectively connecting each layer together. The second research pattern you might encounter is the Continuum. Continuous quantities are in contrast to discrete or binary quantities. Sometimes a better solution isn't in the extreme, but in some sort of midway point. Being able to add this continuous property to a quantity or methodology that was previously discrete or binarized make for interesting discoveries. A good example of this is the LoRa fine-tuning methodology, which allows researchers to train fewer parameters than a full fine-tuning without sacrificing too much accuracy. Usually with fine-tuning, you will take full rank update on all the parameters. However, with LoRa, you can instead land somewhere a bit more in between these two axes, which will allow you to get good enough result at a fraction of the computing cost. This is most useful for massive models. By the way, do check out this YouTube video by Edward Yu, one of the authors of LoRa. The idea behind the methodology is well explained. Another example of a continuous pattern is the QHADAM optimizer that we reviewed last week. The gist of QHADAM is that it creates a continuous plane between having no learning whatsoever and the ADAM algorithm by adding two immediate discount factors. In this plane created by these two variables, you can recover other type of algorithm like RMS prop or NADAM. Doing it this way gives you a more fine-grained control on the bias variance trade-off of momentum-based algorithm, which ultimately help the learning. The third research pattern you might encounter is the merging. Taking two ideas that seems to have complementary property and finding a way to mashing them up together is a very natural tendency. It is one that can create complexity in craft, but that can definitely yield some groundbreaking changes. Good example of merging can be seen in the segment anything paper by Meta. This paper is absolutely full of different ideas being merged together. One obvious display of merging is in the universal segmentation part, where there is a mashup between an image and text encoder like clip with a mask decoder. By mashing these three building blocks, the authors built up something new that can segment any image given enough data. Another good example of merging is the JLU activation function, or Gaussian error linear units. The basic idea sprouted up by formulating an activation function that had the property of both the adaptive dropout and the LU activation function. Some work had to be done to find a form that matched, but the jelly was born out of this mixture of ideas with interesting properties. The fourth pattern that you might encounter is an obvious one. It is the scaling pattern. This one is simple. You try to do the same thing, but way more of it. Usually the author will stretch out the scaling until they hit a natural limit that make them unable to continue, like compute limitation, algorithmic instability, just general weird stuff happening at scale, or a conference submission deadline. A good early example of this is the VGG network, which tried to stretch out the AlexNet network in the depth direction. To do so, they had to simplify a few things like limiting the width, but just stretching out this network in depth yielded great results. This tendency to just push the gas pedal on the scale of something is very apparent in language models. Simply by scaling up the number of parameters available in a GPT model, make it automatically more performant at zero shot, one shot, or few shot learning. This scaling opened up the door for a whole sort of new paradigm like in context learning and prompt engineering. The final pattern you might find is straight up stealing idea from Jürgen. This one is a bit of a joke, but this prolific researcher has some very interesting claims about other researchers being too inspired by his work without credit. Like he has reference for each of these claims that Lecan, Bengio, and Hinton inspired themselves a bit too much without crediting his lab. Remember the residual network? Highway network came in just before, and it's very similar. Fortunately, the residual network folks acknowledge his lab work on that front, but you get the idea. Okay, the interesting takeaway here is not directly about Dr. Jürgen, but more about how research happens in general. It's never like in a vacuum with a lone genius. It's through reading other people's work, looking at their code, listening to a researcher in a podcast, conferences, chatting with them in poster presentations. Being very connected with this kind of melting pot of idea is what allows you to connect the dot properly and create something new. As a closing word, you might see more than one of these patterns being used in research, especially if it's a big one with multiple authors. The main reason for that is that a big research result is usually the combination of multiple research projects that were combined together. Be aware of this pattern, and next paper you will read will make much more sense. And that's it for today. I hope you enjoyed the video. Don't forget to like if it was the case and leave a comment if you have any question. I'm here to help. Have a great week everyone, and see you in next video.